The ground beneath you carries a memory older than mountains, older than oceans, older than anything we usually call history. Long before today's continents took shape, they were stitched together into colossal landmasses that dominated the planet. These were not continents as we know them, but supercontinents. Forests stretched for weeks, and rivers crossed the lands of 5 future nations before ever meeting the sea. Supercontinents were not accidents. They were engines, driven by tectonic plates, enormous slabs of crust floating on the mantle, slowly shifting like pieces on a planetary puzzle. Their collisions and breakups changed the chemistry of the air, rerouted entire oceans, and reshaped the climate in ways that still echo through our world today. Though those ancient giants vanished hundreds of millions of years ago, part of their legacy never disappeared. It is with us right now, moving through you every moment, unseen yet essential to life itself. This is Armchair Archaeology, and by the end of today's episode, we'll uncover how the ghost of a vanished supercontinent continues to flow through one of the most ordinary and vital parts of your body. Before we begin, if you love exploring the mysteries of our planet's deep past, consider subscribing. It's the best way to join us on every journey through lost worlds and hidden histories.
Look at a world map, and it seems complete, even permanent. Continents like Africa, Asia, and the Americas appear as if they have always been separate. But the familiar outlines are just one chapter in a much older story. For most of Earth's history, the continents were not scattered across oceans at all. They were gathered into enormous supercontinents that stretched across much of the globe. Supercontinents formed because Earth's crust is not solid and unbroken. It is divided into tectonic plates, vast slabs of rock that float on the mantle and drift slowly, carrying continents with them. Over millions of years, these plates can push landmasses together into a single vast continent, only to tear them apart again in the next cycle. The scale of these landmasses is almost impossible to imagine. Pangea, the most famous, was so vast that you could have walked from present-day New York to North Africa without crossing an ocean. Its interior was dry and desert-like, while its coasts were covered in forests and swamps. And Pangea was not the first. Rodinia, Nuna, and Columbia came before, each ruling Earth for tens or even hundreds of millions of years before breaking apart. The evidence for their existence is written directly into the planet. Rock layers and mountain belts on different continents line up like torn pages from the same book. Coal seams in South America match perfectly with those in Africa. Fossils tell an even more striking story. The plant Glossopteris, with its broad leaves, has been uncovered in India, Antarctica, and South America, proving that these lands were once neighbors. So while our maps feel timeless, they are fleeting snapshots. The continents beneath us are still moving, reshaping the world in ways we are only beginning to understand.
If supercontinents seem like accidents, Pangea's story proves otherwise. Its creation was anything but random. For hundreds of millions of years, smaller landmasses drifted across the planet, carried by the same slow tectonic forces that move continents even today. Inch by inch, these fragments crept across the planet, colliding and welding together. Over millions of years, that slow-motion drift gathered Earth's scattered lands into one colossal whole, a continent so vast it seemed the planet itself had only a single face. From space, it would have looked less like a world map than a single, endless land ringed by ocean. The process was violent. When plates collided, the crust did not simply merge, it crumpled. As North America slammed into Africa, rock buckled upward to create a mountain chain that once rivaled the Himalayas. These were the ancestors of today's Appalachians.
Time and erosion softened them into rolling ridges, but their bones still stretch from Alabama to Canada. What hikers see as quiet hills were once sharp peaks scraping the sky, monuments to Pangea's birth. And those same forces didn't just raise mountains, they also set in motion changes that still shape the world you depend on today. Speaking of carrying pieces of the past into the present, we've designed something special for curious minds like you, the Ancient Secrets Mug, Armchair Archaeology Edition. It's a daily reminder that even the ordinary, like your morning coffee, can hold echoes of vanished worlds. You can find it in our store, linked below. But mountains were only part of the story. Every collision closed ancient seas, erased coastlines, and redirected rivers. Climate shifted as landlocked interiors dried out, leaving deserts that dwarfed the Sahara. Along Pangea's edges, swampy forests flourished. Layer upon layer of plant material settled there, and over millions of years, compressed into the coal seams still mined for energy today. In that sense, the industrial power that fuels our world is tied directly to Pangea's creation. By around 300 million years ago, the assembly was complete. Pangea stretched across thousands of kilometers, its interior so vast it created its own weather. Identical rock layers still run from Morocco to North America like lines of text across a torn page, proof that these distant lands were once neighbors. Pangea was Earth's greatest union, a world-shaping continent that rewrote the map and reset the stage for life.
Pangea may have seemed immovable, but no continent is eternal. The same tectonic forces that stitched it together eventually began to pull it apart. Heat from Earth's interior built up beneath the vast landmass, forcing the crust to stretch and fracture. At first, the cracks formed long rift valleys where magma welled up from below. Over millions of years, those valleys widened, splitting the continent and opening new oceans. The breakup was anything but gentle. Volcanoes erupted along the rift zones, covering the land with ash and lava. Fault lines tore across regions, leaving scars still visible in today's landscapes. From that fracture, new ocean crust spread outward in stripes, each one freezing Earth's magnetic field in place. Like mirrored barcodes, they prove the Atlantic is still widening. One of the earliest ruptures split apart the junction of North America and Africa. That fracture widened steadily, filling with seawater, and eventually gave birth to the Atlantic Ocean. The process continues even now. The Atlantic grows wider by about 2.5 centimeters each year, the same pace at which human fingernails grow. Over millions of years, that tiny movement will push entire continents farther apart. The consequences of Pangea's breakup rippled across the globe. New coastlines appeared, changing weather patterns and ocean currents. Species that had roamed freely across the supercontinent suddenly found themselves isolated by widening seas. Evolution followed different paths on separate landmasses, driving diversity but also extinctions. Where connected ecosystems once dominated, new and unfamiliar worlds began to take shape. The echoes of this great rift are not confined to the distant past. The Red Sea, stretching between Africa and Arabia, is a living laboratory of the same process. It is slowly widening, hinting at the ocean it may one day become. Pangea's fiery demise was the beginning of the continents we know today, and a reminder that Earth's surface never stops rewriting itself. When Pangea fractured, it didn't scatter into countless fragments all at once. Instead, it broke into two enormous pieces, Laurasia in the north and Gondwana in the south. Gondwana was a titan in its own right, spanning much of the southern hemisphere and carrying within it the ancestors of South America, Africa, India, Australia, and Antarctica. For millions of years, Gondwana was home to vast ecosystems. Dense forests stretched across what are now separate continents. Rivers wound through valleys where herds of reptiles and amphibians thrived. Along its coasts, swamps nurtured plants that would one day become coal seams.
life spread freely across this connected land, building a world that seems alien now, but laid the foundations for our modern continents. Even after Gondwana began to fragment, it left fingerprints that still connect its children together. The puzzle piece fit of South America and Africa is the most famous clue, but the deeper evidence lies in the rocks themselves. Mountain belts and mineral seams run seamlessly across oceans, as though once joined pages had been torn apart. Fossils tell the same story. Glossopteris ferns, Mesosaurus reptiles, and the land-dwelling Lystrosaurus all appear in South America, Africa, and Antarctica, species that could never have crossed vast oceans, yet once lived side by side on Gondwana's unified ground. It's as if fossils became passports, stamped across continents now separated by oceans. Clues like these don't just reveal the shape of lost continents. They hint at how those vanished worlds still echo in our own lives. If discoveries like this spark wonder for you too, you can support the channel directly with the super thanks. It helps us keep exploring stories written in stone and sharing them here with you. The ghost of Gondwana lingers in modern life as well. The mineral riches of Africa and South America trace back to its tectonic past. Antarctica's ice sheets lie atop rocks that were once part of warm, forested landscapes. Australia's unique wildlife, from kangaroos to platypuses, evolved in isolation after Gondwana finally splintered apart. Every continent it left behind carries fragments of its memory, proof that Gondwana may be gone, but it has never truly vanished.
While Gondwana dominated the south, the northern half of Pangea formed another vast supercontinent, Laurasia. It gathered North America, Europe, Greenland, and most of Asia into one continuous expanse of land. Though it is often overshadowed by Gondwana's dramatic story, Laurasia shaped much of the world we know today. Its formation raised entire mountain systems. When fragments fused, the crust buckled, giving rise to ranges such as the Urals, still standing as the boundary between Europe and Asia. The early foundations of the Alps and the Rockies were also set in motion during Laurasia's time. These were not simply scenic landscapes. They were scars left by collisions that stitched the northern lands together, geological monuments that remain central to the northern hemisphere. But perhaps Laurasia's greatest legacy lies in the life it supported. Its vast connected plains allowed species to spread widely, creating evolutionary links that are still visible in the fossil record. Dinosaurs roamed freely from what is now western North America into Europe and Asia. Fossils of raptors, stegosaurs, and ceratopsians appear on multiple continents, proof of ecosystems that ignored the boundaries we see on today's maps. The mighty tyrannosaurs of Mongolia and North America, though separated now by an ocean, shared a common Laurasian stage. Even as Laurasia began to fracture, its influence endured. The widening Atlantic tore North America from Europe, and Asia stretched into the immense landmass we know today. Yet geology still records their kinship, matching rock layers, shared fossil lineages, and landscapes shaped by the same tectonic story. Laurasia may have vanished, but its echoes are everywhere, from the fossils displayed in museums to the mountains people hike today. The North we inhabit is built on the memory of that forgotten supercontinent.
Supercontinents may break apart, but they never vanish without leaving traces. The Earth carries scars from their assembly and destruction, etched into the crust like memories that refuse to fade. These scars shape not only the land we see, but also the resources we use and the hazards we endure. The Appalachians in eastern North America are one of the clearest examples. Today, they look like rolling hills covered in forests, softened by time and erosion. Yet, when they first rose during the birth of Pangea, they rivaled the Himalayas. The gentle ridges hikers walk today are the remnants of a colossal collision between North America and Africa. On the other side of the world, the Himalayas themselves are still growing, pushed skyward as India drives into Asia. Every earthquake in Nepal is a reminder that these ancient forces remain active. But the scars of supercontinents are not only visible in mountains. They lie hidden in mineral seams and resource deposits created under extreme pressure. Goldfields in South Africa, coal in India, and iron ranges in North America all formed during the violent unions of past continents. Even oil reserves are often found in basins created when supercontinents began to rift apart. In a very real sense, modern economies still run on the legacy of vanished worlds. Rift basins became oil fields, while old collision zones turned into belts of copper, gold, and iron. Every time a light switches on or a phone is charged, it's powered in part by those ancient collisions. The scars also shape Earth's systems. Ocean currents bend around ancient continental outlines, while climate is steered by mountain ranges raised hundreds of millions of years ago. Seismic zones frequently trace the sutures where continents once collided, making those old wounds the sites of modern earthquakes. Though the continents move on, their history is never erased. Beneath our feet, the planet still remembers every collision, every fracture, every supercontinent that came before.
On land, the scars of supercontinents are written in mountains and minerals. Beneath the oceans, the story continues in an even stranger archive, the seafloor itself. Unlike the ancient rocks of continents, ocean crust is constantly being created and destroyed, preserving a record of Earth's restless surface in the process. When continents split apart, they leave a rift where magma wells up and solidifies, creating new ocean floor. As the crust spreads outward, it locks in the orientation of magnetic field at that moment in time. Because the magnetic field flips back and forth over millions of years, the ocean floor ends up striped with alternating bands of polarity. These stripes, mirrored on both sides of mid-ocean ridges, are like barcodes of geological time. They prove that oceans expand and continents drift. The Atlantic Ocean offers the clearest example. Where North America once touched Africa, a seam of volcanic ridges now marks the Mid-Atlantic Ridge. From that line, new crust pushes outward, widening the ocean every year. The movement is tiny, about 2.5 centimeters annually, the same rate your fingernails grow. But multiplied over millions of years, it is enough to reshape the planet. The Atlantic is still widening, carrying the Americas farther from Europe and Africa with each passing year. I'd love to hear your thoughts. If you could stand on the edge of a new ocean forming, like the widening Red Sea today, what would it feel like to witness? Share your ideas in the comments. I always enjoy reading your perspectives. These hidden records are more than curiosities. They allow scientists to reconstruct vanished supercontinents and predict future ones. They also reveal where earthquakes and volcanic eruptions are most likely, since spreading ridges and subduction zones mark the planet's most active boundaries. Even natural resources like rare metals and hydrothermal deposits are tied to these underwater scars. The oceans, then, are not blank spaces on the map. They are memory banks, holding the record of every union and breakup, whispering the story of Earth's shifting continents. Supercontinents are not just geological curiosities. By rearranging the face of the planet, they also rewrote its climate. The placement of land and sea controls wind patterns, rainfall, ocean circulation, and even the gases in the atmosphere. Each time the continents fused into a giant landmass, the Earth's climate system was transformed. Pangea offers the clearest case. Its vast interior lay so far from the oceans that moist air could not reach it. The result was an immense desert stretching for thousands of kilometers, recorded today in fossilized sand dunes across North America and Northern Africa. While the center baked under arid skies, the edges told a different story. Along the coasts, forests and swamps flourished in humid conditions, leaving behind the coal beds that continue to power human industries.
The contrast between desert interiors and fertile margins was one of Pangea's defining features. Gondwana shaped climate in another way. For millions of years, it straddled the South Pole, and glaciers spread across regions that are now tropical. Rocks in India, Africa, and South America still bear the grooves of these ancient ice sheets. The presence of glaciers near the equator seems unthinkable today, yet it was once the global reality. These rearrangements of land and sea also altered ocean currents, which in turn drove changes in global temperature. As new seaways opened, warm and cold waters flowed along different paths, flipping Earth between greenhouse warmth and icy ice ages. The lesson is clear. Climate is not fixed, but deeply tied to geography. Today, we see smaller versions of the same principle. The Sahara's vast dryness is the legacy of continental placement, just as Antarctica's ice sheets are. Supercontinents magnified these effects, turning geography into a climate engine that reshaped life on a global scale. That's why deserts like the Sahara and ice sheets like Antarctica's can trace their roots to those ancient arrangements.
Continents are not just slabs of rock. They are the stages where life evolves, adapts, and sometimes disappears. Every time a supercontinent formed or broke apart, it reshaped the possibilities for life on Earth. When Pangea existed, animals could roam freely from one end of the world to the other. Dinosaurs, amphibians, and early reptiles spread across its sweeping plains, while plants blanketed vast regions without barriers. Fossils found in South America, Africa, and even Antarctica reveal species that once lived side by side. For a time, Earth was unified not just in land, but in life. But when Pangea began to fracture, everything changed. Oceans widened, isolating populations on separate continents. Species that had once shared common ground were split apart, forced to adapt to new climates and predators. This isolation sparked evolutionary experiments. In one region, a lineage might grow into giants. In another, it might shrink into smaller, specialized forms. The freshwater reptile Mesosaurus and the stout little Lystrosaurus both left fossils across multiple continents, silent witnesses to life caught in the middle of continental drift. These separations fueled diversity, but also caused extinctions. As habitats vanished or shifted, entire groups disappeared. Yet new coastlines and shallow seas created opportunities for other life to thrive. The rise of flowering plants, the spread of mammals, and even the eventual dominance of birds were all tied to the changing geography that followed Pangea's breakup. The pattern continues today. The unique wildlife of Australia, the mingling of species between North and South America after the Isthmus of Panama formed, and even the spread of humans across continents are chapters in this same story. Continents drift, climates change, and life rewrites itself in response. Evolution has always been a passenger on a restless planet.
If Earth's history shows anything, it is that no map is permanent. The continents beneath our feet are still drifting, carried on tectonic plates that move only centimeters a year. That pace seems trivial, but over millions of years, it completely reshapes the planet. Geologists track this motion with satellites and seafloor maps, and from these clues, they sketch possible futures. 3 futures compete for Earth's map, and you can pick your favorite. In one vision, called Amasia, the Americas drift northward and fuse with Asia around the Arctic Circle, creating a supercontinent near the pole. Another, Novo Pangea, imagines the Atlantic continuing to widen while the Pacific closes, drawing all the continents together on the opposite side of the globe. A third, Pangea Proxima, foresees the Atlantic halting and reversing, pulling today's continents back into a cluster near the equator. Each scenario would unfold over 200 to 300 million years, unimaginably long to us, but only another cycle in Earth's restless history. The seeds of these futures are already visible. The Himalayas rise higher each year as India presses deeper into Asia. Africa is inching northward, slowly narrowing the Mediterranean and hinting at mountains yet to come. The Red Sea is widening, a visible reminder that East Africa is splitting away, destined one day to form a new ocean basin. And beneath the Atlantic, the mid-Atlantic ridge continues to create new crust, pushing the Americas and Europe farther apart year after year. The formation of a new supercontinent would not just redraw coastlines, it would reorganize global climate, alter rainfall patterns, and reshape the habitats that life depends on. Entire ecosystems would vanish while new ones emerged. The map we know today is only temporary. The continents are still on the move, heading toward another grand reunion that will once again transform the Earth.
From the assembly of Pangea to the splintering of Gondwana and Laurasia, from the scars of mountains to the patterns etched into the seafloor, the story of supercontinents shows us that the world is never still. Continents are not fixed, but travelers, joining and parting in cycles that stretch across hundreds of millions of years. And here's the truth promised at the beginning. These vanished giants did more than shape landscapes or scatter fossils. They reshaped the chemistry of the very air. When continents fused, vast forests grew across their interiors, pumping oxygen into the atmosphere and drawing down carbon dioxide. When they broke apart, new coastlines and shallow seas created nurseries of marine life that further transformed the balance of gases. The oxygen we breathe today is partly the legacy of these long-vanished worlds. With every breath, we carry the memory of supercontinents. The continents under our feet may feel permanent, but they are only chapters in a larger story. Another supercontinent will come, just as others have before. It will shift the climate, rewrite ecosystems, and leave its fingerprints on the Earth in ways future beings may one day study. So the next time you take a breath, remember, it carries echoes of worlds long gone. This has been Armchair Archaeology. If you enjoyed this journey through Earth's vanished worlds, share your thoughts in the comments and let us know which future supercontinent you think sounds most likely or most strange. Don't forget to like, share, and subscribe so you never miss an episode. Until next time, keep questioning, stay curious, and remember, the ground beneath your feet is carrying echoes of worlds long gone.